Hello everyone, am I audible? Yeah. So, my dear friends, my voice is audible to you. My dear friend, my voice is audible to you. Okay, hello Praveen. Okay, so we are going to start simple harmonic motion today. No? Good evening. Yes. So everything is set, everything is working properly. Okay. So definitely today's lecture is exciting. Okay, means uh, it is not very much detailed lecture, but it is sufficient lecture. Okay, you will understand it very well. We have some questions, we'll solve it. So half of the lecture we will have today, and remaining half will be tomorrow. Okay. Yes. So Neat Avenger, my dear, you are here. Okay, so all of you, my dear friends, let us start. Okay, so shortly I will introduce myself and I will move faster. Okay, so, welcome to Unacademy. My dear friends, Unacademy is India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country with the quality content and great learning experience. So, here you can see this is a diagram, right? Yeah, image in which a particle is attached with a spring. Particle is attached with a spring. Okay, now what's going on? Particle is just released, so it will go down. Again it will come up, it will go down, come up, go down, come up. Why it is going on, you know? What is the reason behind this activities? Reason behind this activity is the energy stored in the spring when it is extended, means there is a restoring force developed in the spring when its length is increased or decreased. So what will happen? It will just go down, come up, go down, come up. So such type of motion is called simple harmonic motion or oscillatory motion, we can say, right? What is this curve? So this curve is showing you what is the position of the particle, right? So we'll talk about it in details, right? So today's lecture is really exciting. Okay. Yes. So Neat Avenger, my dear, you are saying you are facing difficulty in solving numericals. So how to overcome it? My dear, simply speaking, at first you watch a lecture properly, you understand it properly. First step. Second step, you make short notes of the chapter. Okay, with all formulas and with condition, not complete detailed theory. Just make short notes and keep it with you. Okay, right, and read it. Okay, after that, third thing, you just take a basic book like we can say universal, you know, universal means what? Errorless physics, right? Such type of very basic books you take, right? And after that you start solving question and you will be able to do. Okay, right? Yes. So that is my clear instruction. You can follow it. You just start solving basic book. After that you increase your level slowly. Okay, if you directly go to difficult problems, definitely you will not be able to solve, right? It will decrease your confidence also, right? So try this once. Okay. Yeah. So let us talk about this is called a simple pendulum. What? Simple pendulum means a bob or a particle of mass m is hanging with the help of a string and it is just oscillating like this. Okay, so this is also simple harmonic motion. Okay, so let me introduce myself. My name is Rahul Dagariya. I have been teaching physics since 5 years in the various top reputed institutions of India. Till now I have mentored to the thousands of aspirants of NEET and IIT JEE, and now I am available here to help the students of the country to learn the concepts of physics for NEET UG. Okay, so let's crack NEET UG, my dear friends. We want you to crack NEET UG with the India's largest learning platform, Unacademy. So if you want to crack NEET UG with us, get the Unacademy subscription. And if you did not download the Unacademy app yet, go to Play Store and download Unacademy Learning app. Okay. And after that, you need to get the Unacademy subscription. So what you will get? You will get the daily live classes. Yes, you can chat with us. You know, you can engage in any discussion. You can answer the polls, and you can have a lot of fun. Basically, you know, you can ask your doubts also. You can evaluate your performance. Yeah, definitely to know how much you know, how much you are learning. The evaluation of your learning is very very important, and that can be done only by the test and quizzes. Okay, so we provide you tests and quizzes also. Okay. So next, structured courses. So structured courses, let us talk about the structured courses means entire syllabus physics, chemistry and biology. Biology include both zoology and botany. So entire syllabus you will get it at an academy app. Okay. Unlimited access to the live and recorded courses. If you miss the live lecture someday, then you can watch its recording. Okay. That will always be available on the On Academy app. Okay. So definitely I am saying nothing is going to miss, and you can crack NEET UG. So here Krish is asking, sir, where are you from? I am from Udaipur, Rajasthan. Okay. So next, let us talk about this. Free live classes or free live classes are available on YouTube, right? You are watching now. And our top educators are from IITs, NITs, reputed MBBS colleges and AIMS. They have produced very good ranks. Okay. Yes. So Krish is asking, sir, what is the best book according NEET? Best book for NEET? Okay, according to you. Simply speaking, my dear, the best book anyhow, if you take any book, there will be so many questions, you know. So how much you will solve? So first thing is, if you want to start from basics, you should go for errorless physics. Okay, that is universal errorless physics. Okay, available in the market, you can buy it from Amazon, Flipkart also. Okay, so errorless physics. Okay, yes. After that, okay, yeah, NEET Avenger is asking when will syllabus complete, sir? Okay, my dear, I would like to inform you one thing. From Monday, let me take the yellowing. Okay, yes. So as I'm saying, ki from the Monday, I am going to start the entire syllabus from the first topic. So first topic is what? Kinematics. Okay. From the kinematics to the entire mechanics, and after that entire syllabus, I am going to start. Okay. So you want to get its updates. So this is my Telegram link at the rate P capital RAHUL D at the rate P Rahul D. This is my Telegram link. Okay. On this, I will share the link of the lectures, you know, and PPTs. PPTs also I will share. So I am going to start from the very first topic, kinematics. Detailed lectures will be there. Okay. Okay. Each and everything I will cover. Okay. That's all. So you will learn entire syllabus, or yeah. By the way, I am solving DC Pandey for NEET, and it is good. Right, definitely. Yeah. So as I am saying, ki very basic book I told, that is universal errorless physics. Second number, you can go little higher, you know. Then you go for DC Pandey. Okay. Then you can go for DC Pandey, and after that you further want to increase your level, you know. Then you can prefer HC Verma. No need to go above this level. This is sufficient, more than enough. Okay. So anyhow, I am saying, if you are doing DC Pandey and universal physics, है ना? Universal. That is enough, more than enough. Okay, you will learn everything. That's all. Okay, yeah, definitely. Okay, my dear. Yeah. So thank you, Krish and Neat Avenger. What is your name? I forgot. You told your name, right? I forgot. Yeah. So here I was talking about Unacademy subscription. So let us discuss about it fast. Yes, I want to inform you, my dear friends, if you want to get Unacademy subscription, this is the right time, because very soon the price are going to increase. So 1 month subscription is for 6,000 rupees, 12 month is for 30,000 rupees, and 24 month subscription is for 36,000 rupees. If you use my code RAHULD Rahul D, if you will use this code, you will get 10% discount, and you will get a 1 month subscription for 5,400, and 12 month subscription for 27,000 rupees, and 24 month subscription for 32,400 rupees. Which one is beneficial? Obviously this is equivalent to 5 months, and this is equivalent to 6 months. If you are giving NEET exam in 2021, you should prefer 5 months, right? Okay, 5 months equivalent fee means 12-month course. Okay, which course? 12-month subscription. So definitely, I'm saying ki you can buy for 1 year or 2 years. It is very much beneficial for you. Okay. Yes. To use my code Rahul D and get Unacademy subscription if you really wanna get it. Okay, because prices are going to rise very soon. Okay. So this message I received today morning only, and I'm informing you. Okay. So let's move towards our topic. Our today's topic is simple harmonic motion. So we are going to start simple harmonic motion today. It is not very much detailed lecture, but it is sufficient lecture. You will learn. Okay. Yes. So let us talk about it. At first, I would like to talk about the periodic motion. What is a periodic motion? Okay. So whenever we want to study oscillations or SHM, then at first we need to about a periodic motion. What is a periodic motion? Let's say I have a particle. Okay. This particle is moving along some path and coming back to here. In this entire journey, it is taking time is equals to 10 seconds. How much? 10 seconds. After coming here, again it is moving on the same path and completing this path, completing this journey in 10 seconds. So I am saying that the particle is moving on this path repeatedly in the same time interval. So such type of motion is called periodic motion. Okay, such type of motion is called periodic motion. That's all. Okay, so let us erase this and let's move quickly. You know? So when a body or a particle moving particle, okay, along a definite path after a regular interval of time, its motion is said to be periodic motion. So its motion will be periodic motion, and whatever time it is taking to complete its one round, right? That is called its time of flight. That is called its time of flight. It is represented by capital T. So now only I gave the example for which the time of flight was, sorry, time period, not time of flight. Time of flight is in projectile motion. Sorry. I would like to say in one complete journey, whatever time it is taking, that time is called its time period. Okay, that's all. So let's move. Time period, this is represented by capital T. Okay, let us talk about oscillatory motion. So whenever a particle is doing to and fro motion, just to and fro motion. To and fro motion means which type of motion? You can see this motion, pendulum wala motion, right? Yeah, this motion, to and fro, to and fro motion is there. So this is called what? This is called oscillatory motion. In this diagram, you can see this particle is having to and fro motion and up and down to and fro motion, right? So such type of motion is called what? Peri Oscillatory motion, है ना? Yeah, that's all. So let's move faster. You know what is periodic motion. You know what is oscillatory motion. So let's move towards next. Oscillatory motion is of three types. First type is simple harmonic motion, SHM. Simple harmonic motion, which we are going to study today. Okay. Yes, my dear Nikhil. Good evening. So first, I am saying we are going to study this type of motion. What? First type, SHM, simple harmonic motion. Second type of oscillatory motion is damped oscillation, DAMPED, damped oscillations. Okay. So today we will not discuss about it. In some other lecture, we will discuss about it. This damped oscillation. And third is called forced oscillation. Forced oscillation. Yeah. So what is simple harmonic motion? Whenever a particle is executing to and fro motion without any resistive force, means there is no loss of energy. If there is no loss of energy, means total energy remains conserved. In that situation, the motion is called what? Simple harmonic motion. During the simple harmonic motion, the acceleration of particle is always towards the mean or equilibrium position. Okay. Yes, Sahil. So, simply speaking, acceleration of particle is always towards the mean position. Okay, just a minute. Just a minute, my dear friends. Yeah. So, we are going to start again. Damped oscillation. Damped oscillation is second type of oscillatory motion. So, what happens in damped oscillations? During the damped oscillation, there will be a resistive force. Okay, which will what will happen? Which will eat the energy. We can say, है ना? So which will destroy the energy of the particle. Means energy will be converted into heat because of resistive force. Okay. So because of some resistive force, there will be a loss of kinetic energy of the particle. Okay. So because of that energy loss, slowly the amplitude of the particle will decrease. Okay. Next, force oscillation. So sometimes there is a resistive force. So to maintain the oscillatory motion, we apply an external force on the particle. We apply an external force on the particle, and particle continuously execute what? Oscillatory motion. So such type of oscillatory motion is called force oscillation. Okay. Yes. सर क्या सारे periodic motions oscillatory motions होते हैं? My dear, yes. No. We can say one thing. Listen, all simply speaking, all oscillatory motions are periodic motions. It is not necessary. Here I have written, listen, to and fro type of motions are called oscillatory motion. It need not to be periodic. Are you getting? It need not to be periodic. It can be periodic, it cannot be periodic. Okay, remember I have written here. Okay, Nikhil, it is important point, remember. Okay, because this you can see this damped oscillation, this forced oscillation, you know, in such type of motions what will happen? In such type of motions they are oscillatory motion, but they are not periodic. Why they are not periodic? Because with time their energy will decrease, right? So there will be loss of energy during the motion. So slowly time period may be changed and amplitude also change, right? So that's why I'm saying ki an oscillatory motion may be periodic, may not be periodic. Okay, it is not necessary. Okay, yeah. So all of you got it right. So example, pendulum of a wall clock, right? Okay, NEET Avenger daily take classes for both 11 and 12. Okay, my dear, I will try my best. Okay, right? Yes, I will try my best. Okay, now I am giving lectures, right? Yeah. Okay, so from Monday there will be regular lectures. Okay, daily there will be some lecture, and I will be delivering from the starting from first topic from kinematics to entire syllabus I will cover. Okay, right. So damped oscillation, there is a loss of energy because of a resistive force. Okay, yes. Okay, next I will talk about simple harmonic motion. So as I told, there is an oscillatory motion which is called simple harmonic motion. If there is no loss of energy, there is no loss of energy, and acceleration is always towards the mean position. Means whenever particle is executing oscillatory motion, that will be around a mean position, a fixed point. What is mean position? A fixed point where net force on the particle is zero, means particle is in equilibrium. Okay, a position where the net force on the particle is zero means particle is in equilibrium. That position, that point is called equilibrium position. Okay, so during the oscillatory motion, huh, uh, here Krish is asking what is Telegram. Yeah, my dear friend, my Telegram link is at the rate capital P R A H U L D. Okay, capital P R A H U L D. D is also capital. So this you will use. Okay, so you can join my channel, right? Yes. So simply speaking, now there is nothing in that channel. I have created it completely new. Okay. From Monday onwards, I will share the links. Okay, and entire syllabus we will cover. I will share the PPT also. Yes. So here I was saying what is mean position, the position at which the net force on the particle is zero. Okay, so that is mean position. Remember. Now we are going to move always during the SHM particle. Let's say particle is here. So particle is having acceleration towards the mean position. Okay, this is mean position, x is equals to 0. The acceleration of particle will be always towards mean position. Let's say particle is here, acceleration will be in this direction towards the mean position. Then and then only particle and execute simple harmonic motion. Okay. Yes. So Himanshu, how are you? So let us talk about this. If the restoring force, so definitely as I told, if particle is executing more simple harmonic motion about mean position, here net force 0. Okay. Here acceleration is towards the mean position, the direction of force is also towards the mean position. Okay. So if you are taking particle away from the mean position, the particle wants to come back to mean position. Why? because there is a restoring force. Okay, there is a restoring force. No, don't worry, Himanshu. Uh, lecture started now only. Okay, and everything is going to start now only. Okay, no need to worry. So, simple during the simple harmonic motion, there will be a restoring force. There will be a restoring or conservative force towards the mean position, always directed towards the mean position. Okay, yes. So directly proportional to displacement. So simply speaking, whenever a particle is there and force acting on the particle is proportional to negative of displacement of the particle from the mean position. Let's say this is the particle, okay, this is mean position, and let's say this is the displacement of the particle, that is x. So I will say force is proportional to negative of x. So if we remove this proportionality sign, we will get a constant. So F will be equal to minus kx. Okay, so F will be equal to minus kx. So this is restoring force. This K is called force constant. K is what? K is called force constant. Okay, K is called force constant. X is what? Displacement. Displacement from the mean position. That's all. Okay, so we got this essential condition for SHM. Now we can modify it. How? You can write F is equals to minus kx, so you can write it like this: F is equals to ma. We all know that will be equal to minus kx. So here you will get A is equals to minus of k by m into x. So this is another important formula. A is equals to minus of k by m into x, and it can be written as A is equals to minus of omega square x. That's all. So this is the final formula. So whenever you are getting acceleration is proportional to minus x, means this is essential condition for SHM. Whenever you get such type of relation, means you understand that is SHM. Okay, what is the value of omega? So omega square is root of omega square is k by m, so omega is root of k by m. Okay, that's all. So again I want to write the simple formulas here, so I am erasing everything. First essential condition, F is equals to minus kx, means force is always proportional to displacement and negative of it. Okay, second condition, acceleration, that is minus of k by m into x. How you got? Because F is equals to ma, we know, so we will just put the values, we'll get this. So A is equals to minus of omega square x. So simply speaking, acceleration is always proportional to negative of displacement during the SHM. Remember this. Okay, value of omega is what? Root of k by m. This omega is called angular frequency of SHM. Omega is called angular frequency of SHM. What is K? K is called force constant, and M for mass of the particle. That's all. Okay, so you will get the SHM. Next, let us talk about equation of SHM. What is the equation of SHM? So my dear friend, I am going to derive the equation of SHM. Look at code. F is equals to minus kx, we all know. For SHM, essential thing, there should be a restoring force F, and value of this is minus kx. So minus of force constant into x. For example, let's say there is a spring. So spring constant is k. There is a particle. Okay. So let's say this is in natural length. Spring is in natural length. Now I will displace this block in this direction by a displacement of x. Okay. So what I will say directly, there will be a force developed in the spring. That is spring force. So that is F. So if block will be here, so spring force will be in this direction. Displacement is rightward. So force will be leftward. So directly I will say F is equals to minus kx. Okay, this F can be written as ma is equals to minus kx. Okay, so A can be written as minus of k by m into x. I am going to derive the equation of SHM. Okay, now what you can write, all of you know, v is equals to dx by dt, rate of change of displacement. This is what? Velocity. What is acceleration? Acceleration is rate of change of velocity, means double differentiation of displacement. All of you know that, know this, right? D square x upon dt square. So this is what? Double differentiation of displacement, right? That is called what? Acceleration. You have studied this thing in kinematics. So what you will write? D square x upon dt square you will write. Okay, that is equal to minus of k by m into x, right? Now what I can write here? So d square x upon dt square plus k by m into x is equals to 0. This is called differential equation of SHM. This is called differential equation of SHM. Now I will modify it, d square x upon dt square plus omega square x is equals to 0. So remember this equation always. This is differential equation of SHM. Okay. Yes. What is the value of omega? That is root of k by m. Okay. Root of k by m. So this thing you need to remember. Omega is angular frequency. K is spring constant. Yeah, we can say force constant. M is mass. That's all. I think you are getting it, right? So that's all. This is equation of SHM in differential form. You just need to remember this form, okay? D square x upon dt square plus omega square x is equals to 0. Just remember this form, okay? That's all. If we solve this differential equation, we get an equation x is equals to a sine omega t plus phi. A sine omega t plus phi. So this is called sinusoidal equation of SHM. So this term and this term, these three terms are very, very important. You need to remember at any cost, my dear friends. Okay. So if you understood it, please give a thumbs up. If you are getting it, please give a thumbs up. Okay. So this is a simple thing. There are two forms of equation of SHM you need to remember. First is differential equation and second is sinusoidal equation. Okay. So I am erasing it and now we'll talk about it. F is equals to minus kx. So if we can write it like this. So this equation we got right. Yeah. So remember this equation, very, very important. This is the first equation you need to remember. Next, this is omega is equals to root of k by m. You also need to remember this. And third, this is sinusoidal equation. If you solve this differential equation, you will get this equation. That's all. You don't know how to solve this differential equation because I can't waste your time, and you also don't waste your time. This solving differential equation will come in engineering first year. Okay, so no need to worry about that. Hi Rishabh Raj. So we have studied the differential equation. I have just put the star marks. What are the equations you need to remember? That's all. So let us see this. You can see. Do you know y is equals to sine t? How will be its curve? Its curve will be like this. Its curve will be like this. This is the curve of sine y and t. So this is the curve. Okay. Remember. So here you can see the particle is executing SHM. This is called mean position. This is called mean position. Okay. This is the maximum displacement particle is reaching, right? So this is called extreme. This is called extreme position. This is also, this is the minimum position. So I can say this is also extreme, but this is negative extreme. Okay. So between these two positions, particle is executing SHM. So the distance between mean position and extreme position is called amplitude. What? Amplitude. Remember that. Okay. So you can see particle is coming from here to down, coming back here, going up and coming back here. Right. So in this complete motion, the particle is covering one cycle. This is one cycle. Are you getting? So whatever time the particle will take in this complete motion, that is called the time period of oscillation. Okay, Himanshu is asking what is the real definition of SHM. My dear friend, real definition of SHM I have written here. You can see this. If the restoring force, yeah, there is means we cannot say there is any real definition. Just there is a statement which we can understand. Okay, yes. So simply speaking, SHM is a to and fro motion in which acceleration is always directed towards the mean position. Okay, are you getting? The to and fro motion in which the acceleration of particle is always towards the mean position. Okay, right? And there is no loss of energy. So such type of motion is called simple harmonic motion. Right? That's all. So I have explained this, right? Yes. So remember, let's say particle is starting from here, t is equals to 0. When particle reaches here, so time period by 4. So time will be t by 4. When particle coming back and reaching here, so time will be t by 2. When particle is reaching at this position, time will be 3t by 4. And when particle is coming back here, time will be capital T. Are you getting? So between mean position and from mean position to extreme position, particle take a time one fourth of the total time period. Okay, one fourth of the total time period. That's all. Okay. You will understand everything. No need to worry about that. Okay. So next I will talk about characteristics of SHM. Means basic terms which will be used in SHM. Okay. First, displacement during the SHM. So what is the displacement during the SHM? So I am saying, let's say this is a particle and it is executing SHM along this straight line. This is positive extreme, this is negative extreme, and this is mean position 0. So let's say particle is coming from mean position to this position. So this is at x. So I will say this is in positive direction. So plus x is the displacement. Okay, simple. So displacement of the particle is mean from the mean position is called displacement of the SHM. Okay. Next, it can be given by the equation x is equals to a sine omega t. So I already explained you the equation x is equals to a sine omega t, right? This is sinusoidal equation of SHM. You need to remember. Number two, amplitude. Amplitude is just the maximum displacement of the particle from the mean position. Amplitude is the maximum displacement of the particle from the mean position. So this is x max is equals to capital A. So that is called what? Amplitude of the particle during the SHM. Next, angular frequency. Okay, so particle is covering a complete cycle. Means particle is moving from here to here, again coming back to here. So in this complete motion, you know, we will say कि if we'll compare it with a uniform circular motion in complete cycle, particle cover 2 pi angle. How much angle? 2 pi angle. And time taken is capital T. So we will say angular frequency means number of, we can say directly what? We can say number of revolution per second. So that is what? That is called angular frequency. Its formula is 2 pi upon capital T. And 1 by capital T is called frequency. Okay. So frequency is 2 pi f. Okay. Remember, omega is equals to 2 pi upon capital T. That will be equal to 2 pi f. So this is the formula of angular frequency you need to remember. Okay. That's all. So let's move to the next point. Time period. Time period, we can say the time period can be given by t is equals to 2 pi upon omega. You know? Because omega is equals to 2 pi upon capital T. So t is equals to 2 pi by omega. So remember this formula. Okay. Yes, that's all. These are the basic formulas, basic terms you need to remember. Okay. So let's move to the next slide. Next, I have a simple question for you. A particle performing SHM, equation of motion is given by this. So this is the differential equation of SHM. Okay. Now find the time period. So you need to find the time period of SHM. Can you solve it? I'm giving you four options A, B, C, D. I'm giving you four options. This is the differential equation in front of you. You need to find the time period. Okay. So I'm writing the four options. Just a minute. Yeah. First option is 1 second, second option is 2 second, third option is 2 pi second, and fourth option is pi second. Okay. So what is the time period you need to find? Do it fast. Come on, answer. I am waiting for your answer in the chat. Type it first. What is the time period of SHM? I have written a differential equation of SHM. You just need to compare and answer. Okay. So I think you might be getting it. I am solving it. Okay. Answer is what? Let us check. I know one thing. I know one thing. What? I know d square x upon dt square. Sorry. Yeah. D square x upon dt. This is not dx square. This is dt square. Okay. Upon dt square plus omega square x is equals to 0. You know? D square x upon dt square plus omega square x upon is equals to 0. This is the equation of SHM. Let us compare these both equations. So I can say d square x upon dt square here same. Now this is 4x, this is omega square x. So I got omega square is 4, value of omega is 2, and time period is 2 pi by omega. So we are getting what? T is equals to 2 pi divided by 2. So I am getting pi seconds. So answer is D for dog, pi. Okay, that's all. So this is the answer for this question, right? So many exciting questions are there in this lecture. So let us move to the next slide. Next slide, I am talking about the phase. Phase, right? What is phase? We know x is equals to a sine omega t plus phi. Okay. This first term is called displacement. X is displacement. A is amplitude. A is amplitude. Omega. Omega is called angular frequency. Omega is called angular frequency. T is time at any instant. You know, T is time. And phi. Phi is called initial phase or phase constant. Phi is called initial phase or phase constant. And this entire term omega t plus phi, this is called phase. This is called phase. So what is phase? Phase is a physical quantity which represents the state of motion of the particle. Phase is a physical quantity which represents the state of motion of the particle. Example, its position, its direction of motion. Means at t is equals, at any time t, where is the particle? What is the direction of motion? This all things can be explained with the help of phase. Okay, how you will get it later. Next question. Phase constant. Phase constant, we can say it is initial phase. So at any time. Yeah. So Chandrasekhar, is it okay? This speed is okay for you? Yes, you are from Andhra Pradesh. Okay, I also worked in Andhra Pradesh, Visakhapatnam. Okay, I worked in Fiji, Visakhapatnam. So let us talk about this phase constant. So, my dear friend Chandrasekhar, allow now. Yeah. So let us talk about this phase constant phi. In equation of SHM, we can call phi. This term phi is called phase constant or initial phase. Okay. Yeah. So at t is equals to 0, we will say what? Omega t will become 0. So phase will be only and only phi. So this is only called the phase constant or initial phase of the particle. It gives information about the position and direction of motion of the particle at a time t is equals to 0. Okay. Yes. Yes. Bagunnanu. Okay. So velocity. Let us talk about velocity of the particle. You know one thing. During the kinematics, we know if displacement is x, then velocity will be rate of change of displacement dx by dt. Okay. So dx by dt is displacement of the particle. Sorry, velocity of the particle, rate of change of displacement. Acceleration. So what is that? Rate of change of velocity. Right? We can write like this. Okay. So the rate of change of position or displacement, we can say that is velocity. Okay, how to find velocity? We all know one thing: displacement of the particle during SHM. You know why I am so fast? Because this is a revision lecture. Okay, so no need to worry, everything will be covered properly here. Okay, nothing will be missed. So x is equals to a sine omega t plus phi. This is the basic equation of SHM. This is the basic equation of SHM in which this is displacement. So I want to find the velocity. So velocity is rate of change of displacement. So what I will write? You know its differentiation. Its differentiation will be a omega. Sine will become cos. So a omega cos omega t plus phi. Remember this. So velocity of SHM can be written as a omega cos omega t plus phi. Mind it. Okay. This is the equation of velocity as a function of time. Okay. Oh, you are writing NEET tomorrow. All the best, Chandrasekhar. All the best. So next I will write its formula in terms of displacement. So how I can write? We all know one thing. Sine square theta plus cos square theta is equals to 1. Okay. Here is cos. So I want to convert it into sine. So sine square theta can be written as 1 minus cos square theta. Or sorry, I want to convert cos into sine. So cos square theta is equals to 1 minus sine square theta. Okay. So here what I will do? A is there, omega is there, cos is there. Right? So cos theta can be written as root of 1 minus sine square theta. So I can write here under root of 1 minus sine square omega t plus phi. So this is the formula of what? This is the formula of velocity. So how you will write? V is equals to A is there, omega is there, and root of 1 minus sine square theta. So I will do one thing. Let us take this A inside the root. So I will write omega will remain outside As this a will go inside the root, it will become a square. So a square minus a square sine square omega t plus phi. Are you getting? Under root. So what I am getting here? B is equals to omega is there, a square is there, and you know one thing, a sine omega t is called x. So it is written here, right? Equation of SHM. So a square minus x square. So finally I got the another formula of velocity, that is in terms of displacement. Okay. Yes. Right. So simply speaking, speed of the particle at any position x can be given by omega into root of a square minus x square. A is called amplitude of the SHM. X is called displacement of the particle. Omega is called angular frequency. And equation of SHM as a function of time is a omega cos omega t plus phi. That's all. So these are the two formulas you need to remember. Okay. Yes, NEET Avenger, I know you are giving NEET 2021. I know, I know this, right? Okay. So I think you are getting this formula. So these are written here, right? So finally, what are the formulas you need to remember? This is the first formula you should remember at any cost. This is the second formula you need to remember at any cost, right? Omega into root of a square minus x square. Okay. So next, I will talk about some basic terms. Okay. What is the minimum value of velocity? V minimum I need to find. V minimum. How you will find? So simply speaking, whenever x is equals to V minimum and V max, two terms I have. So whenever x is equals to either plus or minus a, so what I will get? Omega into root of a square minus a square. So I will get 0. So minimum value of speed is 0. What is the maximum value of speed? If x is equals to 0, then I will write omega into root of a square minus 0. So means omega into a. So maximum value of speed is omega a. Minimum value of speed is 0. Okay. So that's all. These are the basic formulas you need to remember. Where will be the minimum speed? So the minimum speed will be at extreme positions. Maximum speed will be at mean positions. Okay. Yes. So Chandrasekhar saying, I'm so sorry that I made you now, sir. If I know you before 1 year, I might drop the physics. Oh my dear, actually, I also joined Unacademy just before 1 month. Okay, so yeah, so it's okay, है ना? No need to worry about that. So NEET Avengers sir, send class notes and daily class schedule in Telegram sir. Okay, definitely I will send. Okay, no need to worry about that. From Monday there will be regular classes. I will send you the timings. I will send you the video link. I will also send you the notes. You know, so all things I will share with you. Right. So I think this much you got it right. This much you understood very well. Okay. So at mean position, speed will be maximum. That will be equal to a omega. At extreme position, speed will be minimum. That will be 0. That's all. Okay. So that only I wanted to explain you. So let's move to the next slide. Okay. Let us talk about graph between displacement and speed. So what is the formula of speed? V is equals to omega into root of a square minus x square. This is the formula in terms of displacement. Formula of velocity or speeds in terms of displacement. So what I can do? Let us square both sides. So v square is equals to omega square into a square minus x square. What next? Let us simplify it. So omega square into a square minus omega square into x square. What are the variable terms? V is variable, x is variable. Amplitude is always constant, omega is always constant for an SHM. So what next? What we can do? Let us take our variable one side, constant another side. So V square plus omega square x square. I am taking this side. That will be equal to omega square a square. Now divide this entire equation with omega square a square. So what I am getting? Listen. V square divided by omega square a square plus x square omega square upon omega square a square is equals to omega square a square divided by omega square a square is 1. Okay. So finally this omega square will be cancelled with this. So finally what equation you are getting? V square upon omega a whole square plus x square upon a square is equals to 1. Beta, this is important. That's why I'm explaining you. Okay, this is little different thing, but I'm explaining you. You know one thing? This equation is of which type of curve? Once upon a time, there was a lecture given by me that was let's play with graphs. Okay, in that I explained you x square upon a square plus y square upon b square is equals to 1. This is equation of ellipse. This is called equation of ellipse. Okay, right. So this will be equation of an ellipse. So curve will be an ellipse between sorry. Finally, what equation we got? V square upon omega square a square plus x square upon a square, that will be equal to 1. So this is equation of ellipse. So curve will look like this. Curve between speed. This is speed and this is displacement. So curve will be like this. Okay. Yes. So this is the minimum speed at negative amplitude and this is positive amplitude, and this is maximum speed. How much it is? A omega. Okay. Where at x is equals to 0. So this is the curve. Okay. I think you got this curve, right? So this is the ellipse, right? Ellipse curve always looks like this. Either this or this. This is the ellipse. So here I have drawn just half ellipse. It can be completed also, but speed can never be negative. That's why I did not drawn it at negative velocity, negative speed axis. Are you getting? Speed can never be negative. That's why I am not drawing it below x-axis. Okay? Yes. So that's all. This is a simple thing I wanted to explain you, my dear. That's all. So curve between velocity, speed and displacement will be ellipse. Okay, so this is the curve. That's all. We got it right. This is what? Ellipse. Remember, that's all. When it will be parabola? Parabola, whenever y is proportional to x square, it is parabola. Okay, yes, but here it is elliptical curve. Okay, let's move to the next slide. Acceleration of the particle. We all know one thing. What? X is equals to a sine omega t. V is equals to a omega cos omega t. If we want to find acceleration, a can be written as dv by dt. So we'll get minus a omega square and cos will become sine. So sine omega t plus phi. Okay. So this is the final equation we are getting for the acceleration. Remember it. How I can write this? I know a sine omega t plus phi. A sine omega t plus phi is called displacement. So minus omega square x we are getting here. So this is the essential condition for SHM. For SHM, what is the main requirement? Acceleration of the particle should be always proportional to the displacement from the mean position and towards the mean position, means negative of displacement. Okay. Hello, Sejal. So this is the basic thing I wanted to explain you. That's all, my dear friends, right? Yes. So this is the acceleration of the particle during SHM. Okay. Yeah. Hello, Sejal. So acceleration at any instant is the rate of change of velocity. So this is a is equals to minus. Yeah. These are the basic formulas you need to remember. Okay, my dear friends. That's all. So this was acceleration. How will be the curve? You know, a is proportional to minus x, means straight line passing through origin, and slope is negative. So curve will be like this. Okay, that's all. This is the curve between acceleration and displacement. है ना? Because a is proportional to minus x, so straight line relationship, है ना? Now it is negative, so slope will be greater than 90 degree, means it will be negative. So it will be like this. So this is the curve between acceleration and displacement. Okay. Next, there is a question for you. Okay. The question is, the equation of the particle executing simple harmonic motion is given. So x is equals to pi sine pi t plus pi by 3. This is the equation. So you can compare it with this. X is equals to a sine omega t plus phi, right? Yeah. So write down the amplitude. So at first, what will be the amplitude of this equation? This is the amplitude. So this will be the amplitude. So I will directly say amplitude will be what? Write in the chat what should be the amplitude. Go on, waiting for you. What should be the amplitude? Yes. So the amplitude will be 5 meters. Okay. Yes. Nice. So amplitude will be 5 meters. Now, second question. Time period. What will be the time period? So I know one thing. Compare this both equation. This is omega, right? Yes. So omega t, that is equals to pi t is given. So value of omega is pi. What pi? Okay. And we know the formula of omega. That is what? 2 pi upon capital T. So that is pi. So what is the value of time period? That is 2 seconds. Okay. Are you getting, my dear friends? So what is the time period for this? The time period for this is just 2 seconds. Okay. That's all. After that, maximum speed. These two questions we have solved, right? Yeah. So next, number 3. What is the maximum speed? V max. I already told its formula. V max is A omega. So let us write its formula. That is 5 is amplitude and omega. Omega is how much? Omega is equal to pi. So 5 pi is the answer. 5 pi meter per second is the maximum speed. Okay. So I think you are getting it right. Nice, Sejal. Yes. So 5 pi meter per second is maximum speed. Maximum speed formula is A omega. Okay. Yes. So this all I have solved, but last question is remaining. So let us solve last question. Yeah. What is the velocity of the particle at t is equals to 1 second? So we need to find velocity at t is equals to 1. Means we need velocity as a function of time. So what is that? A omega cos omega t plus phi. This is the formula, you know. So what we will write? A is equals to 5. Omega is pi. Cos omega t means pi t plus pi. Pi value is given pi by 3. I did nothing. I just differentiated this equation, you know. So I got this. Okay. Now what we need to find? We need to find the velocity at t is equals to 1. So v is equals to 5 pi is there. Cos is there, and let us write t is equals to 1. So it will be just pi plus pi by 3. Pi plus pi by 3. And all of you should know this thing. Cos of pi plus theta can be written as minus of cos theta. Cos of pi plus theta can be written as minus of cos theta. Okay. This is the simple thing all of you should know. In third quadrant, cos is always negative. So here this is theta and this is pi. So what I will get? V is equals to minus of pi cos of pi by 3. And all of you know the value of cos pi by 3. What is the value of cos pi by 3? Pi by 3 is 60 degree. Cos 60 degree is 1 by 2. So 5 pi by 2 meter per second is the final answer. So velocity of the particle at a time t is equals to 1 second is minus 5 by 2 meter per second. This is very important for NEET, my dear friends. Okay. So this is very good question and very important for NEET. Okay. So let's move to the next slide. Question number 3. A particle execute simple harmonic motion as angular frequency this. My dear friend, in this question, what is given? Angular frequency. Omega is given. That is 6.28. 6.28. So you know one thing. This is 2 pi. You know value of pi is what? Value of pi is 3.14. So it is double of that now. So means omega is equals to 2 pi is given. Amplitude is given. Amplitude capital A, that is given 10 centimeter. Okay. Now the following questions are there. What is the time period? So at first I am finding time period. So the time period formula of time period T. Question number A I am solving. Time period time period is 2 pi by omega 2 pi divided by 2 pi. So I am getting 1 second. So time period of this SHM is 1 second. Question number A we have solved. Now question number B. What is the maximum speed? So we know V max. We are going to solve B. So V max we know that is what? A omega. So amplitude is 10 centimeter and omega is 2 pi. Omega is 2 pi. So what we are getting finally? We are getting 20 pi centimeter per second. What we are getting? 20 pi meter per second. If you wanna write the value of this, you can write and you can find the answer. Okay. So that's all. Right. V is equals to A omega. So 20 pi centimeter per second is the answer for this question. If you want, you can put its value and you can get the proper answer in. You can get the numerical value. Right. That's all. So this is a simple thing, right? Okay. So the third question we'll talk about. What is the third question? What is the maximum acceleration? And what is the maximum acceleration? So actually, what is its value? So this will be 6.28, है ना? So we will say this is 60.28 meter per second. Sorry, 62.8. Sorry, we can write it 62.8 centimeter per second, or we can write it 0.628 meter per second, है ना? So we got in centimeter per second also, we got in meter per second also. Okay, so whatever option is given, you have to choose it. I just put the value of pi, nothing else. Okay, that's all. So the third question is, what is the maximum acceleration? So you know the value of maximum acceleration, a max, that is always equal to minus omega. I'm writing just its magnitude, so omega square into amplitude. So what is omega square? So that is 2 pi square into amplitude. Amplitude is 10 centimeter, right? Okay, so what you can write? 4 pi, 40 pi square. 40 pi square centimeter per second square. Okay, or you can write what? 0.4, 0.40 pi square meter per second square. I did nothing, I just converted into meter per second square. Okay, that's all. So the B we have solved, C we have solved. Number D, the speed when the particle is at 6 centimeter from the mean position. So displacement is 6, it is given. So I will write speed V is equals to omega into root of a square minus x square, right? All of you know this, right? So what you will get? For your information, I wanna give you one idea. Value of pi square is always nearly 10. Okay, value of pi square is always nearly 10. Okay, so that's why we'll get 4 meter per second square. Okay, yeah. So speed v is equals to omega into a square minus x square. This is the general formula of speed. Now what you will do? Add x is equals to 6. What you will write? V omega. Value of omega was what? 6.28. You know? You can write 6.28 or you can write 2 pi also, whatever is the form of answer, you have to write accordingly. Minus a for amplitude, that is 10 centimeter square, minus x square, that is 6 centimeter square. Let us solve it. You will get 2 pi under root of 10 square is 100 and 6 square is 36. So what I am getting? 2 pi into root of 64, and value of root of 64 is what? 2 pi into 8. So I am getting 16 pi centimeter per second. Why? Because amplitude 10 centimeter and this is 6 centimeter. Okay. If you want to convert it in meter per second, you can write what? 0.16 into pi meter per second. So this is the speed of the particle at x is equals to 6 centimeter. That's all. So this was also simple question just based on simple formulas, right? And last question, very, very important. My dear friends, this question is really very good. Speed at t is equals to 1 by 6 second, as assuming that motion starts from rest at t is equals to 0. The motion is starting from t is equals to 0 and particle was at rest. So I got one thing. What? Let's see. I am erasing all these things. It is given that motion starts at t is equals to 0, velocity was 0, and velocity of the particle during SHM, where it can be 0, it can be 0 at extreme position, yani ki amplitude. Are you getting? So velocity of the particle can be 0 at amplitude, at extreme position only. So that means whenever particle start its motion from extreme position, what is the equation of motion? That is a sine omega t plus phi. Okay, we know one thing. Here angle is 0, here is pi by 2, here is pi, here is 3 pi by 2, and here 2 pi. Okay, so here I will say at extreme position particle is starting from here. So value of pi I will write 2 pi. What? 2 pi. The x is equals to 10 centimeter sine omega t. Value of omega is 2 pi into t plus value of phi is pi by 2. That's all. Okay, so this is the very simple thing you need to remember. Whenever particle is starting at v is equals to 0 means it is starting from extreme, and at extreme value of phi is always pi by 2. That's all. So now what you will write, x is equals to 10. This will become sine pi by, yeah, all of you know sine pi by 2 plus theta is cos theta. So this will become cos 2 pi into t. I got the value of what? I got the value of displacement. Now let us find the velocity. So v is equals to dx by dt, all of you know. So that will be equal to what? Minus 10 into 2 pi. This multiple of t comes outside. This will become sine, and what we will get? Differentiation of cos is what? Differentiation of cos we can write what? Yeah, so we can write that is minus sine. Okay. So now what you will get here? So directly you will get here cos 2 pi t, है ना? Yes. So this is a 2. Cos will become sine, right? 2 pi, and value of time is 1 by 6 second. It is given in the question. So this is 1 by 6 second. So finally what value we are getting? So finally we are getting minus 20 pi and sine pi by 3, that is root 3 by 2. Okay. So you are getting 10 pi root, means 10 root 3 pi. This is the final answer. Okay. So this is the speed at t is equals to 1 by 6. Okay. We got the final answer. Very simple. You can solve it in another way also. I am going to solve it in another way. Look at this. We all know the formula of velocity. Yes, speed. A omega cos omega t plus phi. All of you know this. At t is equals to 0, v is equals to 0 means x is equals to a. Whenever x is equals to a, phi is equals to pi by 2. Remember this. So v is equals to 10 into 2 pi into cos. Here you are getting 2 pi t and value of phi is pi by 2. We are getting the same value. So cos pi by 2 plus theta is minus cos theta. Sorry, minus sin theta. So minus 20 pi into sine 2 pi t. And a very simple question, right? T is equals to 1 by 6 you will put, so directly you will get minus 20 pi into sine pi by 3. Okay, so finally you will get minus 10 root 3 pi meter per second. This is the final centimeter per second, sorry, because 10 is in centimeter. So this is the final answer. Okay, that's all. Very, very simple question. All of you can do it, my dear friends. That's all, right? So this is the question over. Next, question number 4. A particle is performing simple harmonic motion of amplitude A. Amplitude is A and time period is capital T. Time period is capital T. Find the time taken by the particle to reach 0 to A. So let's say at t is equals to 0, particle was at x is equals to 0. Okay. At t is equals to 0, particle was at x is equals to 0. So what will be the general equation? Means particle is starting from mean position. So x is equals to a sine omega t. That's all. This will be the equation. Why? Value of phi is 0. Why 0? Because particle is starting from mean position. Now we have to find what is the time, find the time when particle reaches a by 2. So I will write x is equals to a by 2 means a sine omega t. Okay, this equation I am going to write here. So finally what I will get? So let us solve it. 1 by 2 is equals to sine omega t, right? A to a cancel. So you know one thing, sine 30 degree means sine pi by 6 is equals to 1 by 2. So if we will compare this both, we will get omega t is equals to 1 pi by 6. And what is the formula of black tracksuit is allowed in NEET? My dear friend, simply speaking, just a minute. I will write the value of omega first. 2 pi upon capital T into T is equals to pi by 6. Pi will cancel. Directly answer will get T is equals to capital T by 12. Capital T by 12. Okay. Yes. So my dear, you are asking me one question. Rabani, you are asking, so black tracksuit allowed in NEET 2020. Simply speaking, don't wear tracksuits and so much like so many like long clothes you don't need to wear. Okay, you just simply just wear simple dress. Okay, if you have like simple t-shirt and such type of like simple dress you wear. Okay, if you have like a suit, right, salwar suit, something like that, you wear that, or you wear jeans and t-shirt, right? So and if possible you wear chappals or sandals for that, right? Don't wear shoes. Okay, because generally what happens in most of the competitive exams, uh, the examiner asks us to remove this all extra things, right? So don't take too much things with you. Okay, just wear simple clothes. Okay, don't wear too much clothes, right? So this is the general instruction. Yeah, so this is a simple thing. Don't write anything on your hands. Okay, don't keep any slip and anything, right? So it may create problem for you. Okay, and just take, if you are taking a box, I think they will just ask you to keep it outside, right? But keep pen, pencils, erasers, everything with you. Okay. Yeah, obviously track pant will be allowed, and you can wear any pant, so you can wear track pant also. No need to worry about that. Okay. Yes, track pant is allowed. If you are wearing tracksuit, I think it may create problem. Okay, so just wear some simple dress, right? You can wear a shirt. Okay. Yes. So that's all. Yeah. If you want to wear tracksuit, complete tracksuit, right? So in that jacket, you wear a t-shirt. If they ask you to remove your jacket, so at least t-shirt will be there with you, right? Yes. So okay, thank you. So let's move to the next question. This question we have already solved. Hai na? So the what time we are getting? T by 12. Okay, T by 12 we are getting here. Okay, so I think all of you understood this, right? If you did not understand, once again I can explain you. At t is equals to 0, particle was at mean position, means x is equals to 0, means phi is equals to 0. So the equation of SHM will be a sine omega t. Okay, that's all. Now the position a by 2, so I will write a by 2 is equals to a sine omega t, or omega can be written as 2 pi upon capital T into t. Now what you can do, 1 by 2 is equals to sine 2 pi upon capital T into t. Okay, yeah, so 1 by 2 will be sine pi by 6. So sine pi by 6 is equals to what? Sine 2 pi by capital T into t. Okay, let us compare this both. So pi by 6 will be equal to 2 pi upon capital T into t. So the value of t is what? Pi by cancel, t by 12. This is the answer for this question. That's all. So let's move to the next question. Very good question it is. Okay. This is very good question. I want to explain you one thing. Listen. I want to give you very important information. Listen. If mean position mean position is at origin means at x is equals to 0, then equation of SHM can be written as x is equals to a sine omega t plus phi. So this will be the general equation of SHM. If second case, if mean position is at x naught, means some position is given, x is equals to x naught is some position is given, at this position we have mean position. What we will write, then equation of SHM will be x minus x naught, because this x represents the displacement. So now displacement from the mean position will be x minus x naught. So x minus x naught is equals to a sine omega t plus phi, a sine omega t plus phi. So this is the general equation of SHM. It can also be written like this: x is equals to x naught plus a sine omega t plus phi. That's all, my dear friends. So this equation you remember. When mean position is at origin, this equation will be used. When mean position is at some position x is equals to x naught, this equation will be used. Okay, mind it. So that's all. Let us move to the quick concept, right? I am erasing this, you know. Another thing. If particle is executing at SHM at mean position, then F is equals to minus kx. What? Minus kx. If particle is executing SHM at mean position x naught, this is at x is equals to 0. Mean at x is equals to 0. This equation will be used. And when mean position is at x is equals to x naught, then F will be equal to minus of k into x minus x naught. This also you need to remember. My dear friends, I gave you two relations. You need to remember these two relations at any cost. I am saying my lectures will be more than perfect. Are you getting? Right? It is more than perfect, more than enough. So mind it. Okay. F will be equal to minus of k into x minus x naught. So this is the thing you need to remember. That's all. So now let us solve the question. Okay, so I am going to solve this question. A particle of mass 2 kg, m is equals to 2 kg. Okay, it is given that f is equals to 8 minus 2x. Okay, so we need to convert it in f is equals to minus kx format. Okay, so we'll convert it. Don't worry. It is released from rest at x is equals to 6. So extreme position. Are you getting? B is equals to 0 at extreme at x is equals to 6. That is extreme. Ex TREME. So this will be extreme position. Okay. So extreme position is where? Extreme position is at x is equals to 6. Now, okay. So now it is given that f is equals to 8 minus 2x. So here I am getting one constant is there. So I need to convert this equation in terms of k into x minus x naught. In this term, I will convert. So what I will do? I have f is equals to 8 minus 2x. So let us take minus common. So if I take minus 2 common, minus 2 is taken as common, so I will get x minus 4. So can I compare this equation with this? Right? What I can write? So I can write k is equals to 2. K is force constant. Okay? So that is equals to 2. And x naught, the value of x naught I am getting 4. Because this is minus x naught and this is minus 4. So minus x naught is equals to minus 4. So we are getting x is equals to 4. Okay, x naught is equals to 4. Sorry, x naught is equals to 4. So we got some basic points. We got some basic points. So from where particle is starting its motion? So it is starting motion from extreme position. So directly we can write what? Mean position. Yeah, let us see the questions. What are the questions? So first question, is particle moving simple harmonic motion? So simply speaking, F is equals to minus 2 into x minus 4. This equation we are getting, right? So this is similar to F is equals to minus k into x minus x naught. And this is the equation of SHM. This is the equation of SHM. So simply speaking, answer for the first question is correct. That is yes. That is yes. Particle is executing SHM. So first answer is yes. Okay. The answer for A is yes. It is executing SHM. Okay. Next B. Question number B. Find the equilibrium position of the particle. What is the equilibrium position? So look at this. F is equals to minus of k x minus x naught. This x naught is called equilibrium. So I will say directly x naught is equals to 4 is equilibrium. That's all. So answer for the B is equilibrium position is that x naught is equals to 4. Number C. Okay, I hope you are getting it. Very, very important. Okay. Question number 2 is solved. Number C. Write the equation of motion of SHM. Okay. Now you need to write the equation of SHM. So how you will write? It is given that V is equals to 0 at T is equals to 6. Mean position is at 4. So I can write like this. Mean position is at x is equals to 4 and extreme position is at x is equals to 6. So what is the amplitude? Amplitude A is equals to x maximum minus x naught. So what I will get? 6 minus 4 is equals to 2. So amplitude of this motion is 2 meter. Are you getting the distance between the extreme position minus minus mean position, right? So that will be amplitude. Okay. So the maximum displacement from the mean position is amplitude. So amplitude is 2. So finally, what you will get? Equation of SHM, you can write x is equals to a. Yeah, you can write x minus x naught, है ना? X minus x naught, because motion is starting not from mean position. It is starting from, sorry, it is starting from mean position, but not, sorry. Motion is not about the origin. It is about some mean position. So x minus x naught is equals to a sine omega t plus pi. Omega t plus pi. Okay, right? I think I need space, so I need to clear this all things. Okay. So listen, what I want to say is, I know x naught is equals to 4. This is mean position. Extreme, sorry, extreme. Extreme position is x is equals to 6. The amplitude will be what? Amplitude will be a is equals to 6 minus 4. That is 2 meter. Okay. Next, I want to find omega. Omega is always equal to under root of k by m. What? Under root of k by m. You know? So here you can see value of m is 2 kg. Value of k is this 2. Okay. Yes. So value of k is 2. So I will write here omega is equals to k by m is 2 by 2. What you are getting? 1. So value of omega is 1. Okay. Now particle is starting from rest. From rest. So yeah, it is starting from rest means it is starting from extreme position, and it is starting from extreme position means phi is equals to pi by 2. है ना? Whenever particle start its motion from extreme position, then phi will be equal to pi by 2. So what will be the final equation? So x minus x naught is equals to a sine omega t plus phi. This will be the equation. X minus 4 is equals to a is 2 sine omega is 1 into t. So t plus phi. Phi will be equal to pi by 2. Let us simplify it. What you will get? X is equals to 4 plus 2 cos t plus t. Only t. है ना? So that's all. Because sine pi by 2 plus t is cos t. So we got the final answer. X will be equal to 4 plus 2 cos t. This is the equation of SHM. Definitely, my dear friends, such type of question you may get in NEET exam. Okay, this is very simple question, but you should know the basics. So if you are watching my lecture and understanding it properly, definitely you will be able to solve it. Okay. Okay, my dear. So let us see this. All of you can see now the next heading is SHM as the projection of uniform circular motion. So you can see, let's say this is the particle and this is moving along a circular path. So this is a uniform circular motion. Uniform circular motion. So particle is having uniform circular motion like this. If I want to compare it with SHM of a particle, so you can see there is a spring block system. So this block is downward, then this uh, particle will also come downward. You can see this is mean position. So I will draw here x axis, I will draw here y axis. Okay, so at any instant I can draw its position. Let's say particle is coming here, so you can see this is here. Okay, so I can simply compare this SHM with the uniform circular motion, with the projection of uniform circular motion. Are you getting? If you are not understanding, in next slide you will understand. Look at this. This is the particle having uniform circular motion, and here you can check this is the particle. Let me take the laser, you will understand in a better way. So let me take laser pointer. Yeah, my dear friends, you can see this is the particle. It is executing uniform circular motion. If I will take its projection along x-axis, I can see this particle's motion is just following the shadow of that red particle. Okay, shadow of that red particle means it is executing SHM. Okay, so we can simply compare any uniform circular motion, okay, with a SHM. How? We will just take projection or component. We will just take projection or component of the position of the particle on x-axis, and it will show that the projection of the particle on x-axis and y-axis are executing SHM. So this is important point. Need ask the questions before, and again it will ask. Okay, so how you can solve such type of things? So let us understand it. Yes. So I am going to explain you, my dear friends. So I am taking yellow ink. Let's say I have a circle. Okay, and particle is executing motion, simple harmonic motion. So I am saying ki the direction of angular velocity is like this, and omega is constant, means it is uniform circular motion. Initially particle was here, t is equals to 0, particle was here. At any time t, let's say particle is coming from here to here. So let's say at a time t particle is here. At a time t particle is here. So how I'll draw its position? So this is the position vector of particle. I'll consider the radius of this circle is a. Radius of this circle is a. So let us take the projection of this particle along x-axis. I will take shadow. So this is the projection. Okay, along x-axis. So I am writing it x. What? X. How much angle it has covered in t times? So I am writing it theta. So what is the value of theta? Theta is equals to omega t, because omega is constant and this motion is executed for time t. So theta is equals to omega t. Simply I will write. So finally, what is the value of x? So all of you know from the simple trigonometry, this is x, this is y, this is theta, and this is a. So directly I will write x is equals to a cos theta, y is equals to a sin theta. So I got, are you getting? So I got the value of x. X is equals to a cos theta. What I got? X is equals to a cos theta. So how I can write it? X is equals to a cos theta. Theta is what? Omega t. So finally equation I will get what? X is equals to a cos omega t. So this is equation of SHM. This is equation of simple harmonic motion I wanted to explain you. Okay, got it? So basically we can see the projection of position of the particle on x-axis and y-axis represent the equation of motion if particle is having uniform circular motion. Okay, yeah, how you can write in terms of sign? So you can write it like this: x is equals to a sine omega t plus pi by 2. You know sine pi by 2 plus omega t is cos pi by cos omega t. So we have write like this. Okay, we have written like this. Okay, we can write like this. We have written simply. Okay, that's all. So one simple question I would like to ask you. Let's say a particle is executing simple harmonic motion in this direction at t is equals to 0. Particle is here. This is y-axis. This is x-axis. Okay, this is omega. So you need to find equation of SHM. Equation of SHM. You need to find equation of SHM for this particle. So how you will find? So simply speaking, you can see that particle is moving at t is equals to 0 here. It will move from here to here. So particle will come here. This is the position vector. What is the angle covered? This is the angle covered theta. This is time t. So theta will be equal to omega t. Theta will be equal to omega t. So now what you will do? So let us take its position on x-axis. So all of you know what, if this is a, this is y, this is x, and this is theta. So this will be a cos a sin theta, and this will be a cos theta. I told you in the direction of theta you will take cos component, and in the direction where you are not having theta, there you will take sine component. Okay, so what you will get? You will get x. This is x, right? So x is equals to a sine theta, and finally you are getting x is equals to a sine, and you are writing theta is equals to omega t. So you got the equation of SHM. That's all. This is the simple answer for this question, and all of you can do it. Okay. If you understood it very well, you can solve the questions, right? It is in NCERT also, and it came in NEET. Okay. So again, it will come definitely. Next, I will talk about the kinetic energy. So, my dear friends, we know the formula of speed is omega into root of a square minus x square. You all know the formula of speed of the particle during SHM, right? All of you know the formula of speed during SHM. So, how you can write kinetic energy? So, kinetic energy can be given by half mv square, half mv square. Okay. Now, what you can write? Half is there, m is there, value of v is omega. So let us write it square. So omega square a square minus x square. So we are getting the formula of kinetic energy. Okay. And all of you know one more formula. Omega is equals to under root of k by m. All of you know this. So what will be the value of k? That will be m omega square. Okay. That will be m omega square. So simply speaking, value of k is m omega square. So I can replace this m omega square with k. So kinetic energy, another formula I will get half k a square minus x square. Okay. So these are two formulas I am getting. This is first formula. This is second formula. Remember this both the formulas. Okay. So this is the equation of kinetic energy, or simply formula of kinetic energy, which you always need to remember. Okay. That's all. So I have written this formula anyhow. Now, some questions. What is the maximum value of kinetic energy? What is the maximum value of kinetic energy? So you can see the formula is half m omega square a square minus x square. What is variable? Constant, 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 constant. And this is variable. What is the maximum kinetic energy at x is equals to 0? Mean position velocity is max. So kinetic energy is half m omega square a square minus 0. So this one. So I am getting this is the maximum value of kinetic energy. What will be the minimum value of kinetic energy? So I can write minimum value of kinetic energy is half m omega square a square minus, yeah, where will be the minimum speed? So v will be minimum, and that will be 0 at x is equals to amplitude. You know, so here I will write a square minus a square means 0. So minimum kinetic energy of SHM is always 0. Okay, these two formulas you always remember. Next, let us talk about position. So my dear friends, remember the formula of potential energy. Potential energy. So potential energy can be given by half m omega square into x square. Remember this formula? So we all know m omega square can be written as k. So another formula will be half k x square. Okay, this is the formula. So this is the formula of potential energy. What is the maximum potential energy? So the maximum potential energy can be written as half m omega square. X maximum is amplitude, so a square. So at x is equals to plus minus a, we will get maximum potential energy of the particle. Okay, yeah, maximum potential energy of the system, right? So all of you are getting it. Next, minimum potential energy. So what is the minimum potential energy? So simply speaking, half m omega square into 0 square, because at x is equals to 0, potential energy will also be 0. So this is the minimum potential energy. Okay, this is the minimum potential energy. Okay, next, total mechanical energy. So what is total mechanical energy? So total mechanical energy is sum of kinetic energy and potential energy. So let us write the sum of kinetic energy and potential energy. So this is half m omega square a square minus x square plus, here I will get half m omega square into x square. Okay, so let us add this both. We'll get half m omega square into a square. So this is total mechanical energy, and that is, this is constant, constant, constant. So always constant. So total mechanical energy is always constant. Okay, right? So simply speaking, total mechanical energy of SHM always remains conserved, conserved or constant. Remember this. Okay, next, maximum kinetic energy is equals to maximum potential energy is equals to total energy, and that is half m omega square a square. So this thing you need to remember. Okay, always constant, right? When kinetic energy is maximum, potential energy will be minimum. And potential energy is maximum, kinetic energy will be minimum. Okay, are you getting? So as I told, kinetic energy is maximum. This. So this is equal to total energy. So at this position, potential energy will be zero. When kinetic energy is zero, the potential energy will be equal to total energy. So potential energy will be equal to half m omega square a square. Are you getting? Next, when potential energy is maximum, kinetic energy will be minimum, means zero. When potential energy is minimum, means zero, then kinetic energy will be maximum, means half m omega square a square. So these are the basic things I wanted to revise. Okay, I wanted to help you to revise. That's all, my dear friends. Okay, so I am going to erase this. Yeah, here I have written everything. Total mechanical energy is written like this. Okay, so the graphical variation you can see the graphical variation. How will be the graph? Okay, let us draw the curve. Let us draw the graphs. I am saying, my dear friends, graphs are important and these are main interest of NEET. There will be 4 to 5 questions from the graphs. Okay, in entire NEET exam. So I have given a lecture. Let's play with graph. Watch that. Okay. Yeah. So what is total mechanical energy? So total mechanical energy. Okay, I will write all the formula. At first, kinetic energy, that is half m omega square a square minus x square. So what is this equation? This equation is downward parabola. Downward parabola. Okay. Next, potential energy, that is half m omega square x square. So this is what? Upward parabola. This is equation of upward parabola. Okay. And next is total energy, that is constant. Half m omega square a square. So constant line. A constant line. Okay. So let us draw the curve. Listen. I have drawn here. This is x-axis and this is, let's say, energy axis. This is just simply I'm writing E for energy. This is negative amplitude. This is positive amplitude. Okay. At first, look at this kinetic energy. Kinetic energy is zero at extreme position. So here and here kinetic energy is zero. Kinetic energy is maximum at x is equals to zero. So kinetic energy is maximum this. So I will draw the curve like this. Downward parabola. Okay. So this is the downward parabola we got. Next, total energy. Let's say the total energy is constant line. So this is the total energy. This is what? This is kinetic energy. Okay, this is kinetic energy. Now, let us draw the potential energy. Potential energy is maximum at extreme position. So here and here, potential energy is maximum. Where the potential energy is minimum, potential energy is zero at mean position. So here, it will be downward parabola. Sorry, upward parabola. So this is upward parabola. So this is the curve for potential energy. So remember this curve. That's all. Right? That's all. This is the curve for kinetic energy, potential energy, and total energy of the particle during SHM. That's all. So let us talk about this question. My dear friends, now we are going to discuss some basic questions. Question number 6. Let us talk about this. A particle of mass 0.5 kg execute a simple harmonic motion under a force F is equals to minus 50 Newton per meter x. Okay. Under the action of a force minus 50 Newton per meter x. This is given. So M is given 0.5 kg. That can be written 1 by 2 kg. Okay. Next, F is equals to minus 50x. So it can be written as minus kx. So value of k, what we got here? The value of k we are getting here 50. Okay, so we have two values, value of mass and k. So what will be the value of omega? Omega is under root of k by m, है ना? Okay, so what will be its value? Value of k is 50, value of m is 1 by 2. So I am getting what? I am getting, yeah, are you getting? This is 50 and this is 1 by 2. So you are getting under root of 100, means 10. We are getting the value of omega is equals to 10. Let's see whether it is asked in the question or not. If it crosses the center of oscillation with a speed of 10 meter per second. So Vmax is given 10 meter per second. Center of oscillation means what? Mean position. What? At x is equals to 0. Center of oscillation means mean position. So at mean position, its speed was 10 meter per second. So I have written Vmax is 10 meter per second. Okay. So I have to find what is the amplitude. Amplitude I have to find. So I know one thing. I know mass. I know velocity. So I know Ke max. Ke max is equals to half m v max square. 1 by 2 into 1 by 2 into v max is 10 square. So what I will get? I will get 25 joule. What? 25 joule. So kinetic energy is maximum. Okay, is equals to half k a square. All of you know this, right? Half k a square. Okay, at x is equals to 0. And its value is what we are getting? 25 joule. So let us write 25. What is the value of k? Value of k is 50. Okay, value of k is 50 because it is given f is equals to minus 50x. So value of k is 50. Okay, so I am writing here half 50 into a square is equals to 25. So 25 cancel. I am getting value of a is equals to 1 meter. So this is the answer for this question. Simple, right? That's all. So if you did not understand one again, I can explain you, my dear friends. Here it is written f is equals to minus 50x. So I can write here f is equals to minus kx. Let us compare this both. So finally we'll get k is equals to 50. What is the mass? Mass is 1 by 2 kg. Or V max is given, that is 10 meter per second. 10 meter per second at mean position means at x is equals to 0. Okay. So now what we can do? So directly I can write k max, that is half mv max square. Half mv max square. And its value, how what I will get? So half m, value of m is what? Half m is 1 by 2. Okay, and value of x, uh, half mv square, so v max, that is 10 square. So finally I'll get here 25 joules. 25 joules. Okay, so what is the value of formula of kinetic energy in terms of amplitude? So half k a square, this is maximum kinetic energy. So 1 by 2 into 50 into a square, this is 25. So if we will simplify, I will directly get a is equals to 1 meter. Okay, that's all. So this is the final answer we are getting. Okay. Okay, my dear friends. So simply speaking, this is the answer. Let us talk about next spring mass system, and also we'll talk about it later, my dear friends. For today, it is sufficient, right? I just wanna give summary of this chapter. Okay, I just wanna give a summary of this chapter. Okay. So as I have already written what uh, the remaining things we'll discuss in the next class tomorrow. So first thing, displacement. Displacement. So we can write the displacement x is equals to a sine omega t plus phi. Okay, where x is displacement, a is amplitude, omega is angular frequency, and phi is initial phase, omega t plus phi is phase. Velocity, v is dx by dt means a omega cos omega t plus phi. This thing you can write. In terms of x, if you want to remember the formula, v is equals to omega into root of a square minus x square. Okay. Next, acceleration. Acceleration can be given as minus a omega square sine omega t plus phi. In terms of x, if you want to write, that is minus of minus of omega square into x. Okay. So these are the formulas I have written. These are the main formulas you need to remember. After that, kinetic energy formula, what you can write, that is half m omega square a square minus x square. Okay. Next, potential energy formula, what you can write, that is half m omega square into x square. Okay, what will be the total energy? That will be constant. Its formula is half m omega square into capital A square. Okay, so these are the basic formulas you need to remember. Okay, this one, and after that this one. Okay, after that, how the curve will look like? So the curve will be like this. This is energy, this is displacement. So the energy, total energy is always constant. So this is total energy. Next, I will talk about kinetic energy. So kinetic energy is zero at mean position, extreme position. This is zero, and maximum at mean position. The curve will look like this. The curve will look like this, downward parabola. Next, potential energy is maximum at extreme position and minimum at mean position. So it will be upward parabola like this. So that's all. We have revised this formula. Okay. Okay. So I have revised these basic formulas. Now some more things are there. Some more things you need to remember. Okay. That is curves. Curves of this. So I am erasing this all. So now let us talk about curves. X is equals to a sine omega t. So how the curve will look like? So the curve between x and t will be sinusoidal curve. Sinusoidal means like this. Okay. Now v is equals to a omega. What is this? This is amplitude from here to here. So this is time period. Okay, remember. And this maximum displacement, that is amplitude. Okay. Next, v is equals to a omega cos omega t plus phi. Omega t plus phi. So let us write just omega t, phi is equals to 0. How the curve will look like? The curve will be cos curve, cosine curve. So this will be like this. Okay, so this is time, this is velocity, this is the maximum value. V is equals to a omega, maximum value. Okay, after that, from here to here, this will show the time period. Okay, right, that's all. So this is a simple curve, all of you understood. After that, yeah, that's all. So these are the simple things I wanted to explain you, my dear friends. Okay, so whatever I explained in today's lecture, everything is very, very important and you need to remember it. Okay, yes. So let me ask a simple question. I am going to ask you a simple question. Hmm. The simple question I'm asking, let's say this is origin x is equals to 0. A particle is at x is equals to root 3a by 2. Let's say particle is at position root 3a by 2. So what will be the, and its particle is at x is equals to root 3a by 2. Okay, and time period, let us consider capital T. What capital T is time period? You just consider that. And the motion of the particle is towards mean position. Are you getting? The motion of the particle is towards mean position. So what will be the equation of SHM? What will be the equation of SHM? First thing, so my dear friends, the question is, what will be the equation of SHM? Next, what is the time when particle is at this position? So let us find it. We all know one thing. What if I draw a circle? Okay, particle is moving from let's say t is equals to 0. So here to particle is coming like this. So particle is moving from here to here and again coming at this point, means motion is this in this direction. Okay, so let us take its corresponding position here. So this is the corresponding position. So how I will find it, है ना? So you can see simply, so this angle, if you know, this is a, this is a, okay, and this is root 3a by 2. Value of x is what? Root 3a by 2. So what will be this angle theta? Theta will be equal to base by hypotenuse, है ना, means we can say cos theta. Cos theta is based by hypotenuse, means root 3 by 2. Means theta is equals to pi by 6. It is pi by 6. So you got the value of theta is pi by 6. And theta is what? Yeah, theta is from here to here. So total angle covered from here to here, total angle is pi by 2 plus pi by 6. Are you getting? Pi by 2 plus pi by 6. So directly I can write what? I can write omega into t. Okay, omega into t is equals to pi by 2 plus pi by 6. You know? So let us write it. What you will get? Directly you will get 3 plus 1, 4 pi by 6 means 2 pi by 3. 2 pi by 3 you are getting. Okay, 2 pi by 3 you are getting, and that is omega into t. So that is 2 pi upon capital T into t, that is 2 pi by 3. So let us find the value of this t. T will be equal to what? Pi pi cancel, 2 pi cancel. This is 2 pi by 3, right? So directly I am getting that is t by 3. Okay, my dear friends. So the final answer we are getting t by 3. This time period is t by 3. Okay, how I found this? I found this with the help of circular motion. Okay, so this is the method I explained you. I can use that. Now the next thing, you need to find the equation of motion. So how to find the equation of motion? So listen, particle is starting from here, it is going here and coming back here. So directly I will write x is equals to a sine omega t plus phi. Okay, yeah, so x is there, and what is the a is, let's say, amplitude, sine is there. Okay, and what is the, this is omega t simply, and what is this, let's say particle is starting from t is equals to 0. Particle is starting from t is equals to 0, so then it will be like this only. Okay, that's all. So x is equals to a sine omega t. Okay, and how to find using this equation answer? How can I find? I can find like this. So this much displacement is what? Root 3a by 2. So I will write here root 3a by 2. X is equals to a sine omega t. So root 3a by 2 is equals to a sine omega t. Okay. What is the value of omega? So I can write here 3 by 2 into a cancel, right? Sine, and here I will write omega, that is 2 pi upon capital T into t. Okay. Yes. So what is the root 3 by 2? What is the value of sines? Sine for this. So that is, one is pi by 3 and another is 2 pi by 3. These two values. When particle is going from mean position and at x is equals to root 3a by 2, so this time will be pi by 3. When particle is going to reaching to extreme and again coming back, so total time here will be 2 pi by 3. So direction of motion will be in this direction. So in this question, it is told that the direction of motion is towards mean position, means we will use this 2 pi by 3. This is not correct, this will be correct for this. So I will directly write 2 pi by t into t. What is the answer? So t will be equal to capital T by 3. This is the final answer. Okay, my dear friends. So that's all I wanted to explain you, my dear friends. This is very simple question, and all of you can solve it. One more question I am asking you. So let's say I have two particles having motion along same about same mean position. The position of first particle is x is equals to a by 2, and position of second particle is x2 is equals to minus a by 2. These are the two positions given for a particle. The particle starts motion from the origin. Okay, yeah, and first particle is coming towards the mean position, and second particle is also coming towards the mean position. Find the phase difference between both the particles. Find the phase difference between both the particles. This is the question. Okay, so I am writing for yeah, so I will draw a circle. In that I am drawing x-axis and y-axis. So I have drawn here, and particle is at x by a by 2. So x is equals to a by 2 will be here. This is a by 2. Okay. Now at what positions it is possible? So it is possible at this position, and it is possible at this position. So at this position particle is going away from the main position, but at this point it is coming towards the main position. So this is the first position. So what will be the phase difference? This is t is equals to 0. Okay. So what is the phase first? Phase number 1, phi 1 is, this is pi by 2, and this is another angle theta. Okay. So pi by 2 plus theta 1. So pi by 2 plus theta 1. So what will be the value of theta 1? So all of you know, so let's say this is theta 1, this is a by 2, this is a. So simply speaking, this angle will be 60 degree. What? 60 degree. Pi theta 1 will be equal to 60 degree. How I got? Array yaar. Sorry. You can write this 30 degree and 30 degree. How you will get? Cos theta will be equal to base by hypotenuse, a by 2 divided by a. So directly you will get 1 by 2. So cos theta is 1 by 2 for theta is equals to pi by 3. Sorry, this is pi by 3 only, correct? No? So theta 1 you are getting pi by 3. So let us write here. So you are getting pi by 2 plus pi by 3. If I'll take its LCM, you will get 2 pi by 3. So first position, है ना? Phi 1 you are getting pi by 3. Sorry, 2 pi by 3. Now phi 2, let us talk about it. So particle is coming this side. So for minus a by 2, this should be the particle's projection. Up now particle is going this side, means x is increasing, means it is going towards negative extreme. But if particle is at this position, means it is coming towards mean position. So I will draw another circle. Okay. Yes. So let us find it. You can do it, my dear friends. This is a by 2. This is a. So what will be this theta 2? So theta 2 will also be pi by 3. What? Pi by 3. Okay. So now what is the total angle? So it is coming from here to here. Means I will say pi by 2 plus pi by 2 plus pi by 2. So total phi 2 is 3 pi by 2 plus pi by 3. Okay. Yes. So now you are getting, if you take its LCM, what you will get? 9 plus 2, 11 pi by 6. Okay. Yes. So what is the phase difference? Delta phi is equals to phi 2 minus phi 1. So 11 pi, 11 pi by 6 minus 2 pi by 3. Let us take its LCM and solve it. So I am writing here. So here I will get, if I take LCM, this will be 6. And here I will get what? 11 pi only. And this I will get 4. So the answer is 7 pi by 4. So the phase difference between 7 pi by 6. So the phase difference between these two particles will be what? Okay, got it. 7 pi by 6. Simple, yeah, you can do it. Okay. So, sorry, you can solve it like this also. A by 2, for a by 2 it is here. That's all. Up now particle is moving like this, and particle is at some this position. So this is also a by 2. Okay, right? What is this angle? This is a by 2. This is a. So this angle is pi by 3. This angle will also be pi by 3. Okay, that's all. So this is pi by 3. This is pi by 3. So let us write total phi 1. Phi 1 is pi by 2 plus pi by 3. Pi 2. Pi 2 will be pi by 2 plus pi by 2 plus pi by 2. 3 pi by 2 plus this one pi by 3. Okay, now that's all. Very simple, right? Now what you will do? Just phi 2 minus phi 1 will be the answer. Okay, so there I made a small mistake I have made. That's why calculation error was there. So we did not get the correct answer. 3 pi by 2 minus pi plus pi by 3 minus pi by 2 minus pi by 3. What final answer you are getting? You are getting pi is the final answer. The phase difference between this both the particle is pi. Okay, that's all. Simple. Over. So I have finished this lecture for today, my dear friends. So I would like to say, please use my code Rahul D and get the Unacademy subscription. Prices are going to be rise. Okay, the price of Unacademy subscription is going to rise, my dear friends. So if you really wanna crack NEET UG, if you are you want to apply for dropper batch, or you want to apply for 1 year subscription or 2 year subscription or any subscription, please use my code Rahul D. Okay. Please use my code Rahul D and get the Unacademy subscription. Okay. So get the Unacademy subscription for 1 month, 3 months, 6 months, 12 months, or 24 months, whatever you want. Use my code Rahul D and get the 10% discount. Subscribe our channel and click the bell icon. You can also watch my lectures on the Unacademy app, right? So there you can like my profile and you will get the answers. Means you will get the all the chapters, right? That's all. So bye bye, my dear friends. Good night. This is for today's lecture. Okay. If you wanna ask something, you can ask me in chat. Come on. If you wanna ask anything, please ask. Okay. So this was half lecture of SHM today. Remaining half lecture we will cover tomorrow. Okay. And I want to say that I will start the complete syllabus from the first chapter, kinematics, to entire syllabus. Okay, from the Monday. So from Monday and onwards, we will have regular lectures, and you will get the entire syllabus on this channel. Okay, so that's all I wanted to tell you, my dear friends. So simply, please use my code Rahul D RAHULD and get the Unacademy subscription. Get 10% discount. Prices are going to rise now. Okay, so if you want to buy it quickly. Okay, that's all. It is sufficient for today. That's all I wanted to say, and I am always available to help you. Right? So you can join my Telegram channel. Right there, you can get the videos of my Unacademy lectures. Okay, so that is what at the rate capital P small RAHUL capital D. Okay, that's all. So at the rate P Rahul D. That's all. You know? Yeah. So that's all. Good night. Bye bye for today. As I told, we are going to start entire syllabus from the very first lecture, kinematics, to entire syllabus. Okay, from Monday. So bye bye. Good night for today. See you tomorrow in the next lecture. That is remaining half of the SHM. Okay. Bye bye.